Okay, this is lesson 14 of Module 6, and we're going to continue talking about categorical variables. In the last lesson, you saw how you could make a two-way table with two categorical variables, and we saw that we could pull a lot of information, ask a lot of questions about the data, and get the information from those tables. We recorded the frequency, which is just the count of, in that case it was responses to survey of ice cream flavors, or there were other examples. But so we looked at the frequencies for each of the different options, and then we looked at relative frequencies. So so we could tell proportions of people surveyed who said one thing or another. Okay, so in this lesson, we're going to take it a step further, and we're going to talk about how we can tell if there's an association between the categorical variables. So in other words, is there an association between favorite flavor of ice cream and whether you're a boy or a girl? And so we could ask questions like that. So we're going to see that here. And so our first example has to do with smartphone use. So here is the data summarized in two tables. And I'm going to ask you some questions, and I'm just going to ask you to pause the video and think about those questions for just a couple minutes. Okay, so first question would be, what are the variables in this survey here? And then what conclusions can you make about smartphone use and gender? And what conclusions can you make about smartphone use and age? Okay. And then could you predict, if you knew someone who was 20 years old, would you expect them to be a smartphone user based on this data? Okay, so you'd have to reference the data to answer that question. Okay, so pause the video and just look at these two tables, and just basically, to sum up the questions that I just asked, just see what these tables are telling you. Okay, so pause and then come back and we'll have a discussion. Okay, so some things you might have noticed on this table. Let's look at the smartphone use and gender first. It looks like for males, 30 out of 40 use a smartphone. So 30 out of 40 is 3/4, or 75%. And then 10 out of 40 do not. So 25% do not, 75% do. And so what about for females? 45 out of 60 females use a smartphone. And if you simplified that fraction, you'll notice that fraction is also 3/4. So 75% of females use a smartphone, 25% don't. So we could say that there's no association between gender and smartphone use, because knowing if I know if you're male or female, it's not going to give me any information about whether or not you do or don't use a smartphone. Okay? So, but if you come over here and look at smartphone use and age, if you're under 40, for those under 40 years of age, 45 out of 50 use a smartphone. That's 90%. 5 out of 50 do not. 5 out of 50 do not, so that's 10%. Whereas look at down here, for 40 years and older, 30 out of 50, or 60%, do use a smartphone, and 20 out of 50, which is 40%, do not. So we've got a whole lot more people who are older not using a smartphone. Okay, so here's my question for that. So if I know someone is 20 years old, would I expect that person to use a smartphone? And so your answer to that question would probably be, well, that person is in this category. They're in the under 40 years old category. 90% of those people are using smartphones. So I would say, yeah, I totally expect that 20-year-old to be a smartphone user. Okay? All right, so that's kind of what these examples are going to be in this lesson. It's kind of common sense, right? It's looking at data and seeing what it can tell us. Okay, so let's look at example 2. Example 2 says that suppose a sample of 400 participants was selected randomly from the middle schools and high schools in a large city. And these are teachers and students. So some are teachers, some are students. These participants responded to the question, what type of movie do you prefer to watch? And the options they were given were action movies, drama, science fiction, or comedy. So they had 4 choices. Movie preference and status were recorded for each participant. Okay? So 2 variables were recorded. What were they? Okay, so the variables that were recorded were movie preference and status. So you would have, whether you're a teacher or student is your status. And so those were the 2 variables recorded, and these are categorical variables, right? Because they represent categories. Teacher, student are 2 categories. You're one or the other. Movie preference, there's 4 categories within that variable. Okay, so it's a variable that has categories, not numbers, right? But we're going to record frequencies for these variables. So here are the results of the survey, and they are put in this 2-way frequency table. Okay, so we've got the 4 different types of movies and the student-teacher rows. Okay, so we're going to ask a number of questions here, A, B, C, and D. So I'll look at the first one and let you work on the rest. So what proportion of participants who are teachers prefer action movies? Okay, so what is this question asking? It's asking me, out of all the people who are teachers, what proportion prefers action movies? So reading that, there were a total of 100 teachers, and of those, 40 preferred action movies. So this is a frequency of 4/10. 4 out of 10, or 40 out of 100, participants who are teachers prefer action movies. Okay, so pause the video and answer B through D. Okay, so all of these are asking what proportion of participants who are teachers. So these are all going to be out of 100. Out of 100. So drama movies. So there were 20 out of 100 teachers who preferred drama movies. There were, for science fiction, we have 10. So this is 1 out of 10. And then for comedy, there were 30. So this is 0.3. Okay, so those are the relative frequencies for those different movie types. Okay. let's move on. All right, so the answers to those that you just found, the answers to exercise 2 are called row relative frequencies, and we talked about that in lesson 13. Notice that you divided each cell frequency in the teacher row by the row total, so total number of teachers. So here is a table of row relative frequencies. And so we've got, we had 0.4, 0.2, 0.1, and 0.3 for comedies. Okay, so that was for the teachers. Now we're going to do, I'm going to have you do this. Find the row relative frequencies for the student row. Now remember, there were how many students? We had 300 total students, so we want to find those proportions. Okay, so go ahead and pause the video and work on that. Okay, so to do this, I know I have 300, I'll just do a little bit of the math over here. Out of 300 students, how many preferred action movies? Well, we've got 120 preferring action movies. 120 over 300 is 0.4. Okay, so I can put that in there. Okay, so for drama we had 60 out of 300. Okay, which is 1/5, which is 2/10, 0.2. Oh, are you starting to see something happen here? What proportion of participants who are students prefer science fiction? Well, science fiction was, there were 30 students who preferred that out of 300. So that's going to be 1/10. 30 over 300 is 1/10. And for comedy, we had 90 students prefer that, so that's 90 over 300, and that comes out to 3/10. Okay, so, which is also, like, these are also percentages, right? We could think of them that way. 40% of students prefer action movies, 20% of students prefer drama, 10%, and so on. Okay, so is a participant's status, i.e. teacher or student, related to what type of movie he or she would prefer to watch? Why or why not? So I'd like you to pause the video and either discuss it with somebody or just think about it. Think about, would knowing if someone is a student or teacher help you to predict their movie preference? All right, hopefully you had a chance to think about that. So, so the answer here would be, is a participant's status related to what type of movie he or she would prefer to watch? No. It doesn't appear to be. No, because, I'm not going to write all mine out, but I'm going to say the answer. Because their preferences appear to be exactly the same between students and teachers. 40% of students prefer action, 40% of teachers prefer action. 20% prefer drama in both cases. So teachers and students are just as likely to prefer the same type of movie. I mean, in the same proportions. Okay. And this, and we can see this by the row relative frequencies, by this table of row relative frequencies. Okay. All right, so looking at number 5, what does it mean when we say there is no association between two variables? Discuss this with either someone you're watching the video with or think about it on your own. Okay, so no association between two variables would mean that knowing one doesn't help us to predict the other one. So knowing if someone's a student or teacher does not help us to predict whether they're going to prefer action or drama or comedy or science fiction. So let me write that. Okay, so look at number 6. Notice that the row relative frequencies for each movie type are the same for both teacher and student rows. When this happens, we say that the two variables, movie preference and status, are not associated. Another way of thinking about this is to say that knowing if a participant is a teacher or a student provides no information about his or her movie preference. What does it mean if row relative frequencies are not the same for all rows of a two-way table? Okay, so we're going to see an example of that in a minute, and what it means, what it can mean, is that there is an association between the variables. Okay, so let's continue on. Okay, you can also evaluate whether two variables are associated by looking at column relative frequencies instead of row relative frequencies. A column relative frequency is the cell frequency divided by the column total. For example, the column relative frequency for student action cell is 120 divided by 160, or 0.75. So let's look back at the table to see why those numbers. Okay, so there were, if we look at the total here, there were 160 people surveyed who said action was their preference. 120 of those were students. So 120 out of 160 is 75%. If you do the math, that would be 75%. So let's go back. So we could calculate the column relative frequency. So we've got 0.75, 75%, and here 0.25. 25% of the people who said they liked action were teachers, and 75% were students. So let's go ahead and do that for all of the columns. So if you do that, so let's look at drama. We've got 80 people said they liked drama, 60 were students, 20 were teachers. So 60 over 80 is also 6 over 8, or 3/4, 75%. 20 over 80 is 1/4. Okay, let's look at the next one while we're here. 30 over 40, 75% of the people who liked science fiction were students. 25% of them were teachers. Okay, so and that's going to hold true. Look, it's holding true for every row. 90 over 120 is 0.75. 30 over 120 is 0.25. And same thing with our totals. 300 out of 400 is 0.75. 100 out of 400 is 0.25. So what you're going to end up with here is this. Okay, so in every column, part B asks, what do you notice about the column? Well, they're equal. They are equal for all 4 columns. And so what could you conclude about association based on column relative frequencies? Well, it would appear that because the column frequencies are the same for every column, that there's no association between the 2 variables, between status and movie preference. Okay, let's write that. Okay, so there's a simple response to that. This shows no association. I think it's a little easier to think about in with the row frequency in this case, because it's really easy to see here. 40% of students prefer action, 40% of teachers prefer action. The column frequencies are telling us something else. They're telling us 75% of people in the survey preferred, who were students, preferred action. Sorry, it's telling us that of the people who preferred action, 75% were students and 25% were teachers. Of those who preferred drama, 75% were students, 25% were teachers. And it's that way for every column. And remember, it was that way for the totals too. It's just right here, totals. So in our survey, 75% were students and 25% were teachers. And that is what we would expect if there were no association. We would expect that that these column frequencies would match up all the way across. Okay, I hope that's clear. And think about it a little bit more if you need to. All right, we've got another example here. So we're going to stay on this theme of movie preference. So in the survey described in example 2, gender for each of the 400 participants was also recorded. Some of the results are given below. 160 preferred action, 80 preferred drama, and so on. You can see the results there. All right, so in exercise 8, we're going to use the results from example 3 to answer the following questions. So we need to first fill in the two-way frequency table. Okay, so and also you'll notice that you need to correct your handout, because it should no longer say student and teacher. It should say female and male, because we are summarizing movie preference and gender. Those are our 2 variables now. Okay, so we're going to have to, from this information, fill in the table. So I'm looking here to see that 240 participants were female, so that must mean that 160 were male, right? Because there were 400 altogether. 240 female, 160 male total. 240, 160 gives us 400 altogether. So see if you can fill in, pause the video and fill in the rest of that frequency table from the information you were given. Okay, so again, the question that we might want to answer from this data is, do we think that movie preference is equal among males and females? The data in our other example showed that movie preference was equal among students and teachers. So now we're going to try to answer the same question about males and females. So let's get this table filled in for you here, and you can check your work. Okay, so there you go. So you can check your work on that. You had to do a little bit of critical thinking to fill in every cell, but all the information was given that you needed right here. You just sometimes had to do a little subtracting to figure it out. Okay, so what proportion of the participants is female? All right, so of the total participants, so out of 400, 240 are female. And so that represents a proportion of 0.6, or you could think of that as 60%, right? So 60% of the participants were female in this survey. All right, let's move on. If there were no association between gender and movie preference, should you expect more females than males or fewer females than males to prefer action movies? And then explain your thinking. Okay, so hopefully you paused and thought about that. If there were no association between those two variables, between gender and movie preference, because there were more females in the survey, we would expect more females to choose action movies as their preference. Just simply because if the proportion's going to be the same, there's going to have to be more females than males checking that as their preference because of the total numbers in the survey. Okay, so you could explain that in your own words. Okay. All right, so number 11, we're going to make a table of row relative frequencies, just like we did for the first example. And we're going to have a female in the top row and then male in the bottom row. So correct your handout on that. This is female and male, not student and teacher. Okay, so we're going to get some row relative frequencies. So remember, there were a total of 240 females and 160 males. I'm just going to give myself a little more data here. So there were 60 females who preferred action, so that would be 60 over 240, which ends up being 1/4, right? So this is 0.25 of the females preferred action. Okay, so let's continue on with females. So the number of females who preferred drama was 78. So 78 over 240 is equal to, and please use your calculator for this. This is a perfect problem to be using a calculator on, unless you just really want to practice your division. A lot of these you can do in your head, and you should if you can. Science fiction. How many females? There were 8. 8 out of 240 preferred science fiction. Okay, so that proportion is 0.033, and so like 3%, 3.3%. And so for comedy, we're going to get about a third, 0.392, more than a third, preferred comedy. All right, so pause the video and do the row relative frequencies for the males in the survey. And remember, these are going to all be out of 160, because that's the total number of the men who completed the survey. Okay, so check your work here. There were only 2 males who preferred drama. Science fiction was 20% for the guys, and 1625 for that, about 16% of males preferring comedy. Okay, so there are our row relative frequencies, and you should notice something right off the bat about this, that there's not the pattern to it that there was with the student and teacher. Okay, so let's look at a couple questions about this survey. We are told, we're going to look at 12 and 13 right now. So we are told that 1 out of the 400 participants is randomly chosen. And we're asked to use the table of row relative frequencies that we just made to answer the following questions. Okay, so let's look at 12 and 13. If you had to predict what type of movie this person chose, what would you predict? Explain why you made this choice. And then number 13 adds something to that. If you know that the randomly selected participant is female, would you predict that her favorite movie type was action? If not, what would you predict and why? Okay, so look back at your table of frequencies, and you can also look back at just the plain old frequency table here to answer these questions. Okay, so if I want to know if that participant, which movie, if I want to try to predict what they would pick, it would probably be action, right? Because action has the highest proportion of it's the highest preference. And that's actually easier to see in the frequency table, because we have 160 people choosing action, whereas only 80, 40, and 120 for the other choices. Okay? So I would know, if I had to predict, I would predict action. And my reason is the largest proportion overall whether it's men or women chose action. Okay, so that would be my reason. Now, looking at number 13, if I knew that that participant was female, would I predict action? If not, what would I predict and why? Well, if I know that that person is female, I'm going to look here on my relative frequencies and say that 39% of the time, 39.2% of the time, the females chose comedy over the other genres. So if I know they're female, then that's where I'm going, is to predict comedy. So I could say no. I would predict comedy. Because the largest proportion of females chose it. Okay, and I can see that by the relative frequency of that. So number 14, if knowing the value of one of the variables provides information about the value of the other variable, then there is an association between the two variables. Is there an association between the variables gender and movie preference? Explain. I would add something to this statement that according to this survey, is there an association? So we would say yes. Knowing gender helps us predict preference, movie preference. Something to that effect. Okay, and additionally, the reason I know that is because the row relative frequencies are different. Okay, so it's the mathematical way of knowing that there's an association. It's not just my opinion. There's a mathematical way of showing that association by looking at those relative frequencies. All right, last question here, 15. So what can be said when two variables are associated? Read the following sentences and decide if the sentence is a correct statement based upon the survey data. If it's not correct, explain why not. More females than males participated in the survey. Yes, that's correct. Males tend to prefer action in science fiction. Well, let's look back and see. Males tend to prefer action and science fiction. Those were the two highest relative frequencies on our table. So that is correct. Being female causes one to prefer drama movies. Okay, well, more females than males preferred drama by a long shot. However, one of the things we talked about when we were doing scatter plots is association does not imply a cause-effect relationship. So just because they're associated doesn't mean one causes the other. Imply. Did I say something else? Does not imply a cause and effect. Okay, so you have to be really careful about that. We had an example back in the scatter plots. I don't know if you remember, we had the data, and I think it was whenever there was an association between sale of ice cream on the beach, and number of swimmers who needed to be rescued. And someone might want to say that ice cream consumption causes drowning from that data. But it's not a cause and effect. It's merely an association. There's more ice cream sales. There's probably more swimmers in the water, and more swimmers it would be likely that more would need to be rescued. So you can't, just because two variables are associated doesn't mean one causes the other. So it's important to be careful about what assumptions you make from data. All right. So I'm going to let you read the lesson summary, and it talks about how to use math, to show association between two of these categorical variables. And of course it has to do with looking at the column relative frequencies and the row relative frequencies. Okay, so that concludes Module 6. one more module, module 7 left to do. We're going to talk a lot about irrational numbers, more about the Pythagorean theorem. So that'll be a little bit of a change of pace. So I would recommend doing the end of module assessment so that you know how you're doing on this material, and then move on to module 7.